Welcome to How to Build a Robot course, motors. Specifically, motor mounts. You get a lot of people ask that question. I have this N20 motor and I want to put it in my antweight, or I have one of these repeat robotics motors and I want to put it in my antweight. So go ahead and grab your favorite CAD. I'm going to use Fusion 360 for this one. And I've already got a couple models already loaded. With this little Google, you can Google, N20 motor 3D model, and you can get yourself a fairly stable copy. Go ahead and slap that bad mammer jammer in there. So this is the primary motor that you'll see a lot of people using. And eventually they will bump their ways up to some of these. These are like repeat robotics motors. And they'll go ahead and they'll have a design and they'll go, I don't really know how to secure this. What works for one will work for the others. So, we're assuming that you've got your motor, and I prefer to put them vertically like this. You don't have to, but you can. You can put them flat ways, sideways, it doesn't matter. The easiest way to do this. Alright, and we're going to go to the top here. We're going to create a sketch on this plane. We're going to say, let's say you designed yours and you got this piece of armor here. You want to build your motor into this piece of armor. Right, it's 3 mil by 20. It's a pretty good size. Right? And you're not quite sure what to do. Well, you have a couple options. First option, right-click on the face of your thing. Project. Now, you might have to click it a second time, and I'm not sure how to do this in other softwares, but I'm pretty sure there's a similar feature. Make our body disappear, and our motors disappear temporarily. And what you're left over with after that projection is this. Now, this is where your drive would be. And these are where you can put two little, I think they're M2, M1.5s, or I think they're M2 bolts into the motor. And if you take that and just, I like to grab that, modify it, give it a little bit of wiggle room, 0.15. Say the same thing with the other one, 0.15. That was the offset feature. Just grab, boom, boom. And you know what? We'll do the center hole while we're at it. We're going to give this one a little extra wiggle room. So instead of 0.15, we're going to go 0. I don't know. 0.5. We're going to have half a millimeter extra wiggle room. Because I like to make sure everything's spins nice and free. And you just go ahead and grab. Finish sketch. Pull out your armor wall or piece of thing that you want to mount it to. Extrude. Drag it through. Make sure you've got the cut function. It should do it automatically. Theoretically, there you go. That's really it. Now, if you want to be fancy, what you can do is modify chamfer. I'm a big fan of doing this. You chamfer these edges. Okay? I go for 2 distance. And what you can do is come in here. Get in. Now these are M2, so you don't have to go very far. Right, we're going to go in half a millimeter. Go out 1. And that puts a nice little chamfer for screws to sit in. Means you want to print this side facing down. Or straight up and down. And that'll give you a nice place to put these screws. The other thing you can do, now we may have to, on here, we're going to break this link, unground from pairing. I will go over what those mean later on. Just know that you don't need them right now. Go ahead and move. I'm going to move point to point. So you're going to see this inside circle here. I'm going to grab that. We're going to go ahead and grab this circle here, which should line them up very perfectly. And then we're going to free move. We're going to take this, and to allow for error, we're going to back it off minus 0.1. So there's ever such the slightest gap, because reality is prints aren't perfect, things aren't perfect, and nothing lines up perfect. So you build a little imperfection in. Right? And you can see how this all lines up, those holes. When you get the bolts, put them through, you just want to make sure they aren't surpassing the edge of this plate. Okay, so you only get a couple threads in. You're like, well, that doesn't feel very secure. Well, that's fair. Well, good thing we've already got a sketch made. Right? And what we can do, we can take this whole sketch, reopen it. We'll flip it backwards. Go around the outside. We'll add another 0.15 millimeter gap. We're just going to select it, finish. And what we're going to do is we're going to extrude, capture that position. We're going to start from the object. We're going to start from here. Okay, 0.25. You don't need to go in very far. You can do, if you're really, really nuts, you could, half a millimeter, but you don't have to go in very far. Now, this is about as far as I would really go. Now you have a pocket for it to sit in. Okay? And that should sit in there nicely. Now, 3D printing, that may be a pain in the butt with that overhang. So, something you can do to help this 3D print. Set a chamfer on this top edge. Okay. I'm going to push that up. Just on this top edge. Okay. And now it'll print up. Now, it won't perfectly sit in there, but it should 3D print quite well. These holes might need a little help and a little sanding when you're done, but that should 3D print. Just standing up just like that. And now you've got a really good, solid motor mount. And you can go ahead and you could probably scoot this in, because we did it by 0.5 millimeter, so we can go ahead and scoot this in by 0.5. And it'll sit right in that pocket, nice and handy. And there's not much of a reason to do more than this, but this can be a pain in the butt, the M2 screws, whatever else. So there is one more alternative method that I like to use. Okay? And the reason why I like to put mine vertically instead of flat. Now you can do it flat, this will work too. Is because, first off, grab this very top flat edge, project, capture this. Okay? I'm just going to capture these. Just to capture that so we know where that is. Okay. Now, you see it captured it, but as a flat plane, which means we can go ahead, open this sketch up, create a solid rectangle. There. You can choose to do this one as well. I don't think I'll be sitting in it that far, but you can make it meet all the way up to here, ever so inclined. Right? Now this is on top. Now sometimes probably do this on the bottom, wherever else. Go ahead and start from here. And let's say you do actually want it from the bottom. Okay, so, oh, I made it on the wrong. Go ahead, go from object, extrude from the bottom. I'm going to go ahead and pick it up. It'll fit. And if you want it to be like a very exact, what you can do is extrude distance to object. Get it exactly to the bottom. Okay. Now, make sure you make anything like this motor. Make it disappear. Otherwise, when this joins, join into the motor. Okay. But remember that little offset we built? So we're going to extrude this face object into this little groove offset. What is going on here? Type distance. Oh, there we go. It'll cut that little tiny plane off and make it nice and flat. Now, here's the great rocket science. Put your motor back, and you'll have this. You'll see this portion here that's a little off, different. Take this. Project. Okay. You could also select the entire base of that. We're going to make the motor disappear again. Now we've got this outside like edge highlight. Okay. Well, I don't really want to use that whole edge. We developed a little lip. I don't want to use that whole edge. So we're going to go into the sketch. I come in here. That's me. Draw a little line. Here. That's it. I'm going to close off this bottom. Now, you could, if you felt like extra security, make these sides a little wider and wrap it up around the side, holding it firmly in place. Doing that, you may not even need to bolt that in. Alright? You may not need to build an inset or anything. All you need is this little cradle. So we're going to go ahead and grab it. We're going to extend it. Object, bunk. There. Very, very simple. There'll be a slight separation, so grab the bottom. Set it down. There are much better ways to do this. Yes, I am aware. I have the knowledge. But we're going to do this simply as if we're trying to level off all of our surfaces there. Make it nice and pretty. Okay, and now this isn't truly necessary. You want to do this kind of crazy, ridiculous chaos nonsense, you can absolutely go nuts. I like to make it pretty so there's not all kinds of different heights and weights and sides. And alright. Now here's where it's going to get complicated, and this is where people start overthinking. I need to over-engineer this. Nope, you don't. Sketch is on this part right on the bottom. Funk. You've made a rectangle. You've made two squares. You've now made some triangles. Right? And you can even go as fancy as pressing on these, pressing X. Turns them into construction lines, because we don't really need them for anything. Now we're going to put in this line. Right from the center. Straight to the bottom till it's square. Square. Oh, that one's being funny. Press L to make a line. We're going to do the same thing on the other side. Nice and square. I don't know why it made me overextend it, but... And now we've got two center points here. You have two options. Option 1. Make a 2mm circle. Option 2. Go down to create, polygon. Circumcised polygon. 2. Now, 1. Get it roughly the right size. Now, the reason you would do this is so that when you 3D print, you don't just have a square overhang. You could just carve a rectangle out, and you'll see what I'm doing here in a moment. I'm going to take that, extrude that all the way through to the other side. Punk. That's it, your motor mount's done. But that's not very secure. Nope, not until you add zip ties. There's some zip ties under there. Zip, 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 zip. That's it, your motor ain't going nowhere. Alright, now for this particular weight category, that's fine. Just a couple zip ties, that's all you need. Anything more luxurious than that is more weight. Weight is your enemy, especially when you're playing with anything that is going to be using an motor. But that doesn't mean this is the bin end all be all. If you look at open up Light Force here. And Light Force has got, this fancy drive system and all the rest of this, and this is a 1-pounder. We're going to go ahead and shut that off because I design the drive system separately from the robot. Alright, we're going to go ahead and shut off the hub and one of the drives here. You'll see I have this. Kind of fun little... It sits in there. You can see it's cut out to the shape of it. This will be made out of TPU, so it's very shock mounted. Bolted right in. Because I don't want to put bolts all the way through it. I also, double up, is this bolt goes through as my axle. And this one goes through this piece that holds the gear on. Now these aren't the final gears. Final gears I use are slightly different. They're placeholders. But that's... you could go as fancy as this. But the reality is, zip ties are all you need. Especially in the 1-pound category and under. Just a block. Use this flat edges that you can. Round it out so it's nice and cradled. Flat edge. Just zip tie it. That's it. Save weight. And a lot of us will just take that front face, right, and just bolt it right to the frame. Bunk, bunk. Won't even build the rest of this. The motor will just be hanging on the inside. Don't need a lot at these small weights. Really don't. You don't want to build it fancy. You want to build parts that are easy and cheap and quick. Just, oh no, something happened to my motor. Cut. Motor. Out. New motor. In. Zip tie. Zip, zip. New motor, go. Maybe touch a solder, or, quick connects, or quickness of repair is something you want to think about. So, something as simple as this is, 1, this is more than strong enough to survive combat. 2, it's really fast to repair. This is what I would do for anything smaller than a certain size. Sometimes, if you're building a really, really small robot, and I'm just going to go ahead and rotate this. Right, and let's say you've got it spun that way, right? And you built it into the frame with this little thing, flat part for it to sit on, right? Again, you can surround it with zip ties. Or you build in the edge and you just bolt on the roof, and the roof just touches the top of it. Just make sure that if you do bolt things in, you want to be careful not to have your threads come past here into the machine. Because there's going to be gears in there. Don't want those gears to get messed up. Now, hopefully this helps. If you have any questions, let me know. And we'll move on to the next more complicated subject. Because this is just the beginning. Things do eventually turn into slightly more complicated in the future. This is a 4-wheel drive system that involves taking a brushless motor, gearing it to get more power, in which case then it turns into a 4-wheel drive via that. And what this does is hides my motor back here, so it's no longer back here, so which means I got plenty of back clearance room and not going to whack my motor. I got plenty of front clearance room, and it moves it back ever so slightly, which keeps the weight slightly forward, which allows me to push. There's lots of reasons you would change. But for right now, just slap some wheels on it and make it move. Till next time, the Pawn. Bye.